For 2 marks, asks us to determine whether the stationary points in each case is a maximum or a minimum point. It's only 2 marks. Now, without seeing the mark scheme, I'm not sure whether you would get the marks for knowing the general shape of a quartic, which is that, and therefore, because it's a general shape of a positive quartic, which we do have, and therefore knowing that the first point is going to be a minimum, the middle point is going to be a maximum, and the third point is going to be a minimum again. If you've done that, I would, for only 2 marks, reckon that you're going to get all marks. But just to be safe, I'm going to go through the standard procedure, which is to find the second derivative and go from there. So I'm going to differentiate the derivative that we got in part 1, the dy by dx from part 1, and substitute these x values in just to make sure that I definitely get all marks. So the initial derivative was 8x cubed take away 2x. So when we differentiate that again, 8x cubed is going to go to 24x squared, and the minus 2x is going to differentiate to just minus 2. So for the x equals 0 term, or stationary point, d2y by dx squared is just going to be negative 2. This is going to be 0. And because that's a minimum, because that's a negative number, that will be a max point, a maximum point. For the other 2, so let's do the positive 1/2 first. d2y by dx squared. If we substitute 1/2 into here, 1/2 squared is 1/4, so that's 24 over 4. Take away 2, which is 6 take away 2, which is 4. So we get a positive number this time, meaning it's going to be a minimum point. And for negative 1/2, d2y by dx squared is going to be 4 again, because when we square a negative number, we're going to still get a positive answer. So it's going to be the exact same writing as we've got up there. So minus 1/2 squared is positive 1/4, so we've got 24 over 4 take away 2 again, which is 4, and therefore that's a minimum point as well. So my initial discussion about using the graph, or just knowing the shape of the graph to help you, would have been correct. Here's our 0, here's our minus 1/2, and here's our plus 1/2, and we've got a maximum point at 0 and minimum points at the plus or minus 1/2.